I'm an architect. We're located in Coaldale, just south of Sydney. And I've got a little practice with my partner, Betti Knut. And we've been practicing probably in the last, almost the last 10 years, but more part-time. But we've sort of, 2 years ago, we went full on our own practice. We mainly work in residential and education spaces and use the Passive House standard as essentially the basis for for everything that we're doing, and generally use cross-laminated timber as the choice of material and construction for our projects.
Fantastic. And you've been part of some really cool projects, and your own personal home that you designed in CLT, I understand, won a few awards, so you've got some great experience there. But a project we're speaking about today, equally impressive, is about the demountable schools that you've recently been part of. Can you tell us a little bit about that project?
Yeah, so this is a project that we recently finished with the German International School in Sydney. The school is located in Terry Hills, and we were working on a master plan originally. And as the first project, we developed a science center that's going to be built to the Passive House standard and in mass timber. That's currently sitting with the Northern Beaches Council, and we're waiting for the approval of the DA. And in the meantime, there were lots of little bits and pieces and smaller things coming up, but one of them was that they've got a relatively constrained site with the existing classrooms, and they were looking to increase their capacity for classrooms. So we were originally just tasked with organizing 3D mountable classrooms for them, which we did, and they were looking at purchasing them. And when I was looking into the costs, it was actually getting a bit frustrating, considering how traditional demountables are built, the quality that you're getting, and also the request to be environmentally friendly and sustainable and energy efficient. So there was not really the right option there, and the costs were relatively high for what you were getting. So that's when I started a discussion with one of our installers that we use, Rayco Pacific. And we just said, there must be a way that we can meet these costs that we're getting here and provide something better. And that's how the whole project started. And I have to say, the school was very open to this approach, which was great. And yeah, the project started, we started the discussions in June last year. And sort of by the end of July, we were at the point where we said we can essentially go for this and order the demountables, and in late January, beginning of February, they were installed on site.
It's really interesting because a lot of projects, they don't start with cost as the reason why they go to mass timber, but maybe in this case it was a bit different, that you were confident that you could actually do it cost efficiently. So how did you unlock cost efficiencies here? Because you end up anyone who's seen it's clearly a much better product than the alternative. But to do it at a more cost efficiently, it's a real game changer. So how did that happen?
I guess I think the way that we approached this was really essentially forget about architecture to start with, and let's see how we can get the costs down. And part of it is obviously how much can we fit into a container if we're shipping this, how efficient can this be done, and that was the starting point. I have to say, obviously the project is looking quite nice, and I wouldn't say it's not architecture, but it wasn't the starting point. It wasn't first designing something and then trying to make that work, but it was more like, okay, what can we do? And things that were done, for example, there are some horizontal shelves included, which were turned into an architectural element, but the main purpose originally was to reduce the height of the CLT panels so that we can fit them in a container and don't need to use an open top container. And these are things that developed in consultation with the installers.
Yeah, it's a concept I've heard, probably yourself as well, is that I might get mixed up now. Function follows form, or form follows function, one or the other. But it sounds like essentially from a DFMA point of view, starting from manufacturing. So you got a lot of your panels shipped from overseas and then went to a third party offsite modular builder. Can you tell us a little bit about that process?
Yeah, so all the demountables were produced by Rayco Pacific in Canberra. So they organized a large hall to build these. So there were 5 modules per classroom. So we had overall 15 modules, which eventually filled the whole warehouse. These were then transported with a truck to Sydney in the right sequence to be installed, and then the actual modules were installed within 90 minutes for each classroom.
Well, connecting them together, I'd imagine there's potentially a risk of gaps at the connections, and you're trying to achieve passive house. I mean, how do you achieve passive house when you're connecting these modules together?
So each module was put in place on top of those steel posts that were in place, obviously. And then there is a double seal tape in between, attached to one side of the module. The next module gets put into place, pulled back, and then essentially the gap gets close to almost zero because of the compressible tape in between. That's forming the airtight barrier between 2 modules.
Do you see 3D modular as high potential going forward? Because for those listening, obviously you've got 2D where you go panelize and you install it on site, or 3D you install in the factory and you dropping it in. So do you see that as something that'll stack up on more building types than this, or what do you think there?
I think it depends on the task and on that you've got ahead of you. I think for demountable buildings, obviously the main thing is that to work with the legislation and the SEP exempt development, it needs to be a portable building. So it makes total sense to build this as a modular building. Also for other smaller projects, it might also be an option, where you can put crane something in to a place that might not be as easy to reach. In general, I think that there's both ways, and it really depends on the task. Definitely there's a way for modular for certain tasks there.
Looking at passive house specifically, do you see CLT and mass timber as something that helps enable passive house, and in what ways does it help you achieve these objectives?
Yes, definitely, and that's part of the reason why we're using CLT as well. The one thing with passive house is achieving the airtightness. I guess with a more frame building approach, there's always a bit the risk. You essentially need to find experienced and good builders to do something like this, to work with airtightness, because the concept is not that well known in the Australian construction industry. And obviously, if you've got a panel, if you've got a framed building with membranes over the top, you have to be very careful of not damaging those membranes over the course of the construction, which is easily done with CLT and an airtight cross-laminated timber wall. The advantage is obviously once you've got all the joints sealed, even if some major damage would happen to the wall from the outside, it doesn't really matter in terms of the airtightness. So for us, it is part of a risk reduction in building a passive house.
And achieving airtightness, and is moisture a big thing to deal with as well? And is heat recovery ventilation always part of the package deal for passive house buildings?
Yes, the heat recovery ventilation is always part of it, yeah. Obviously, when you've got an airtight building, you still need to allow fresh air into the building. I mean, obviously you can open windows, but when it's too cold or too hot outside, you've got always the option of leaving everything closed and using the heat recovery ventilation to bring in sort of pre-temperatured air.
I might be putting you on the spot a little bit here, Knut, but is there like any data on the cost savings in the energy efficiency or the overall business case towards passive house? Because when we're trying to demonstrate the benefits of mass timber, it's any way you can look at the cost savings is always helpful. So is there any data or anecdotal sort of evidence on this?
I mean, anecdotally, definitely what we can say is, for example, the Bergola house, a CLT house, which was built in 2019, they've been able to always have between 21 and 22 degrees during all of winter without any heating. So I think that's some data that is I think, pretty impressive. Considering that in normal houses, or let's say in traditional houses, you might experience something like 12, 13, 14 degrees if you're not heating. So to keep that temperature, I think that speaks for itself. But generally, you're saying with the passive house standard, obviously there's a whole process that for all of the calculations, but with the passive house standard, you achieve a reduction of 90% in your heating and cooling loads for a building, which is a lot. And I think now that energy prices are going up, I mean, they're always going up, but I think they're probably going to be going up a bit more now. That will be even more important.
Mm. So you designed something here that was 3D modular, and I'm guessing might be able to be used again. So like a modular design that can be repeated going forward. So can you tell us a little bit about that? It's like that concept of, you know, design it once, build it many times versus design it once, build it once. Do you see that as a potential here? And what implications has that sort of design paradigm got for the industry of architecture in general, these sort of changes?
I mean, I guess, again, it's the question of the task that's ahead of everyone. I think for a demountable classroom, obviously, there will be slightly different approaches for different schools. They're always going to have a different site, unless it's a completely flat site. But again, I think every task is slightly different. But in terms of the demountables itself, yes, the design is repeatable, I would say. I think there's always work that can be done. Things can be improved. Obviously, this was a prototype, which was also developed, I'd say, rather quickly to get this over the line. And yeah, for the next demountables that we're doing, we will be reviewing what we've done there and see where can things even be improved further from what it is now.
Well, what overall lessons learned have you got? And I mean, you don't have to take it just from this project. You've got extensive experience now in probably more than most in Australia. So what lessons have you learned through working with mass timber buildings now, and lessons learned to take into other projects going forward?
One is probably not to underestimate the sites. Obviously, there's when you work on a project with prefabricated or projects or partially prefabricated mass timber, there's a lot of focus on the actual building itself, but everything else around it is obviously also adding to time and costs on any project. So I guess the site is always an important factor. Other things, we are obviously now in a situation where the building industry is in a bit of a disarray, I'd say.
Yeah.
And taking into account that different parts of the building might take much longer than anticipated or than usual is something that we will always need to keep in mind when going forward at the moment, until you can come hopefully to a more stable situation from a global point of view.